All right. How we doing, folks? So we're looking at, this is Mr. Dell, and I am looking at, this is CPM CC2 Section 3.2.4, specifically number 3-73. All right. So it wants us to take what we know and show that 2.3 times 5.06, show that multiplication. Okay, or let's read it as 2 and 3/10 times 5 and 600ths, right? Show that multiplication, that product, as a fraction multiplication problem and explain why the answer is in thousandths with 3 decimal places. So I'm going to rewrite. I've got 2 and 3/10 times 5 and 6/100ths, right? And if you look at that, as I'm even reading it, I'm reading it properly, the decimal, but the way you read a decimal is how you would also write the fraction, right? So this can be written as 2 and 3/10, right? 2 and 3/10. So I'm reading that 2 and 3/10 and I'm writing it as a fraction. And I'm going to multiply that times 5 and 6/10, or excuse me, 600ths. 5 and 6/100ths, right? Because it's in the 100ths place. So it's 5 and 6/100ths. So there's our product written in fraction form. So I'm going to show this problem like it asks me to using fraction multiplication. So in order to multiply these two fractions, they're right now currently in mixed number form. We need to put them in fraction form, right? As looking at this in a single fraction, right? If we remember how to do that, I'm just going to bring it on down. We would take the denominator times the whole number, add it to the numerator, and that becomes our new numerator, right? So it's 10 times 2 plus 3. So it's 10 times 2 is 20, plus 3 is 23. So this is 23/10. And in this one, the same way, 100 times 5 plus 6, 506, right? So 506 over 100. So this is now it as a in fractional form. Now I can do the multiplication. So with multiplication of fractions, you multiply straight across. So 23 times 506, right? We would do that. We could do that with the standard algorithm. I'll do that on the side real quick. So we get 18, carry the 1, 3 times 0 is 0, plus 1, 1, 3 times 5, 15, and then continue on, placeholder of 0 here, 2 times 6, 2, carry the 1, 2 times 0 is 0, plus 1 is 1, and then multiply, you get 2 times 5 is 10. When you add 8, 3, 6, 1, 1, you get 11,638, right? So 11,638 is my numerator. And if I look at my denominator, I multiply straight across, I get 10 times 100, which is 1,000. So interesting, we go back up here and it says explain why the answer is in thousandths, right? Well, look what I have as a fraction. I have 11,638 over 1,000. So if we read this again the way it says a fraction, this is 11,638 1,000ths. So what is that as a fraction, as a decimal? 11,638 1,000ths. So if I take and divide the 1,000 into that number, right, and put this into decimal form, putting this in decimal form, you would divide the 1,000 into the numerator. And when you do that, that 1,000 goes into 11,638, goes into 11 holes, and then there would be a remainder of 638, right? And that would be that 638. Let me rewrite it as a mixed number so I can show you what I'm saying here. So this is 11 and 638 over 1,000. So that is the mixed number of this fraction. So if we think about what that is saying, that's 638 thousandths. So that's why we can rewrite this as a decimal to say it's 11.638, because it's 11 and 638 thousandths. And there's the thousandths place. There's my 3 decimals. So this is fraction multiplication of those decimals. But I want to also clarify and show the connection of how this multiplies in as a decimal. In decimal is the algorithm for multiplying decimals, right? When we multiply in decimals, so this is multiplying as decimals, right? The product as decimals. You would actually first just rewrite the digits without a decimal place. This is the process of multiplying numbers with decimals. Look at these numbers without decimals, without the decimal. So rewrite it as 506 times 23, which should look familiar. We did that already, and I won't redo the algorithm. We get 11,638, right? When I multiply just these numbers without the decimal place, the digits without the decimal. So why did I do that? Because that's the process of multiplying decimals. Then you go back to the original problem and you count how many digits are in the decimal place. So how many digits are in the past on the right of the decimal? On the right of the decimal, we have 1, 2, 3 digits, right? There's 3 digits on the right in the decimal. So therefore, the same thing would be true with my answer. I would start my decimal at the end, and then I bring it over 1, 2, 3 times. And that's where this 11.638 comes into play. Or, as I said before, 11 and 638 thousandths, right? Written as a fraction, written as a decimal, and using the decimal operation, how there's that connection and that similarity. All right. So I'm going to just do A at this point, and that should hopefully give you enough information to do B on your own. Okay, there you go.